So when 9 factorial is expressed as an integer in base 9, the result ends in m zeros, and the last non-zero digit immediately preceding the m zeros is n. What is the value of the ordered pair m, comma, n? And so with these kinds of things, it's important to first get the m zeros. So we're going to try and figure out how many zeros 9 factorial ends in, because before we do that, there's no way that we're going to get n. The problem statement. When n factorial is expressed as an integer in base 9, the result ends in m zeros, and the last non-zero digit immediately preceding the m zeros is n. What is the value of the ordered pair m, comma, n? And so now we're going to try and figure out how many zeros 9 factorial ends with. And basically what that is 9 factorial, like divided, the remainder when 9 factorial is divided by 9. So let's build out 9 factorial. So 9 factorial equals 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And so we know that 3 divides 9 factorial. How many times? Well, it divides it 9 over 3 plus floor of 9 over 9, which equals 4. This is a nice formula. I think I've talked about it before. Like anything, like some prime p divides the number of times that p divides n factorial is n over p, the floor of n over p plus floor of n over p squared plus floor of n over p cubed, all the way until this becomes 0. And so that means that 3 divides 9 factorial 4 times, which is pretty nice. So that means that 9 divides 9 factorial 2 times through. And so that means that m equals 2, and 9 factorial ends with 2 zeros. And so now we're left to figure out what the non-zero part of 9 factorial is. So we calculate 9 factorial over 9 squared. And this equals cancel these. This equals 8 times 7 times 2 times 5 times 4 times 2 times 1. But what we really want is we want the last non-zero digit. We don't really care about the specific value. So now we just need to find what this number is when we divide it by 9. And so we'll use modular arithmetic. So we know that 2 times 5, that multiplies to 10. And 10 leaves a remainder of 1 when divided by 9. So we can get rid of those. We don't care about that. Similarly with 1, that won't affect it. And then with 8, this becomes 8. I guess I'll pause. Okay, so this is congruent to 8 times 7 times 4 times 2. We can combine the 4 and a 2, so it becomes 8 squared times 7. But 8 is congruent to -1 mod 9. So this is congruent to -1 squared times 7, which is congruent to 7 mod 9. So that means that n equals 7. And we already got that m equals 2. And so that's our ordered pair, 2, 7.